Shall I proceed, sir?
Yes, yes, go ahead, go ahead.
Let's start.
Okay. Starting shale. So in today's presentation, I will be covering 7 points. That is, what is shale, its composition, its formation, its classification, its importance to the petroleum industry, and what are its the key points that key points of the shale. And today we will start. Sorry, now I will start with the what is shale. So what is shale? Shale is laminated or fissile clastic sedimentary rock that composed of predominance of silt and clay, other minerals, and especially quartz and calcite. In other words, it is a general field term for a fine-grained laminated sedimentary rock, which mostly consists of clay minerals and appreciable quartz and feldspar silt, commonly considered to have at least 50% particles smaller than 0.062 millimeters. Characteristic properties of shale is breaks along thin laminae or parallel layering or bedding called fissility. It is most abundant sedimentary rock. And the composition of shale in a category of sedimentary rocks is known as mudstone. The mudstone of a basin that are its principal source rock for petroleum for the mineralized fluids that source many sedimentary ores. And because of their low permeability, muds and mudstones inhibit the vertical flow of petroleum, mineralized fluids, and fresh water. Shale is also used as a term for any consolidated terraneous fine-grained rocks, which is laminated or not. You can see an image of a shale having different colors, that is red shale, brown shale, and a black shale. It varies because of its composition. So next we will see the composition of a shale.
Hello, Pushpak.
Yes, sir.
Okay, so now when we are talking of shale, so as you go, can you go back to the slide, the previous slide?
Yes, sir.
Okay, previous one more. The first slide. Okay, so when you say shale is laminated or fissility structure, right? Clastic sedimentary rock, right?
Yes.
So if someone asks you like how it differs from clay and how do you classify clay and shale, what would be the key point here to describe it?
Sir, its property of a facility, that is this rock to split easily along the closely spread parallel layers. Means the layers are parallel to each other. The property of facility can distinguish it from other sedimentary rocks.
Okay, so basically, this was a question for me in an interview, and the thing was what like what I know is clay is basically a structureless body, like it doesn't have a structure, and shale has a fissility structure, laminated. So that would be the difference. Okay.
Yes, sir.
Okay, go ahead. Okay, go ahead, man.
Okay. Next is composition. Shales are composed of silt, clay minerals, and quartz grains. Uh, Tiny grains are usually clay minerals such as illite, kaolinite, smectite, other clay-sized minerals particles such as quartz, chert, and feldspar. So generally, they are in gray colors. In some cases, the color of the rock is different. A minor constituent alters the color of the rock. And these constituents include organic particles, carbonate minerals, iron oxide minerals, sulfide minerals, and heavy mineral grains. And because of these constituents, the color of the shale also differs. You can see black or gray shales result presence of greater than 1% of carbonaceous material and indicate a reducing environment, while red, brown, green colors are indicative of ferric oxide, iron hydroxide, and micaceous minerals. you can see red shell, which is color of a red, comes from the hematite, that is ferric oxide. There is a geothite, limonite, which are the iron hydroxide, which shows brown and yellow color, or the micaceous minerals, that is presence of fluoride, biotite, and illite, will show a greenish color. Organic matters, very important component of carbonaceous, very important component, carbonaceous material in the shale rocks. This is the organic material that usually occurring in the rocks as kerosene, that is a mixture of organic components with higher molecular weight. Although kerosene does not form more than 1% of all the shells. Some shells, especially rich in organic matter, this type rock is called oil shale. Oil shale may be used as fossil fuel, although it is relatively dirty fuel because it usually contains lots of unwanted minerals with it. You can see in image it's a microscopic image where you can see various shells in a that is a red shell, brown shell, gray shells, presence of limestone, sand grains, consolidated sands, etc. Moving ahead, the formation. The formation of a fine-grained sediments generally require
Okay, Pushpak, sorry to disturb you, interrupt you. You can go back to slide, previous one.
Yes.
Okay, this is a microscopic view, right?
Yes.
Okay, so basically, have you done the description about the samples?
No, sir.
Okay, fine. So when you are saying that it contains sand grains and then limestone, then brown shale, red shale, gray shale. Okay. So basically, I'll just give you an idea like how it is. Like suppose when we are drilling and we get a sample, right? Because this is a microscopic slide, so I just wanted to add on it so I don't forget it. So the thing is, when the sample comes out on the shale shaker, we collect the sample and we have to describe it, right? So basically, when I see the sample, we have to describe it in a percentage wise. Okay, so now you can see the sand grains, you can see the limestone, you can see the shale part. So when we describe on the field as an percentage. So now when I see here, so basically I have like percentage wise, maybe I may be like differing. Like you may see shale, suppose 20%. I can see shale for 20-25%, and you will describe sand grains say about 10%, and then limestone for about. So this is like one slide for 5 meters. What it describes the lithology. Okay, for that 5 meter, that 5 meter will be the interval. I will go in detail later on. So just now when I see the slide, I have to describe it. So I'll say I can see greenish shale with 25%, and then sand greens. I will describe a bit of sand and then lime. And then we will give them a percentage. Say sand is about 30%, 20% is shale, and rest is limestone, and so on. Okay. Okay,
Okay,
you
sir.
got my point?
Yes, sir.
Okay, fine. You can go ahead.
So the formation of fine-grained sediments generally require weak transporting currents and quiet depositional basins. The shales are typically deposited in a very slow-moving water and often found in lakes and lagoon deposits. The shale environments thus include deep ocean, the continental slope, and the rise. The deeper and the more protected parts of the shelves, shallow seas, bays, coastal lagoons, interdistributary regions of deltas, swamps, lakes, and river floodplains. The formation starts from the compaction and consolidation of silt and clay grade minerals. The continued compaction results in further loss of moisture and orientation of clay and platy minerals that takes place in parallel layers. So, and if orientation does takes place, the deposit attain the property of fissility and can be called as a shale. So while this the compaction takes place, the shells are the facility, the property of facility deposit, attains the property of facility, and if it gets further compacted without any facility, it may be a sand, it may be a mudstone or a clay stone, and not a shell. So the shell is differed from other rocks, sedimentary rocks, due to its property of a facility. Next is classification. Shells are fissile plastic sedimentary rocks formed from transportation, deposition, and compaction of detrital materials of silt and clay. The fissility of a clay is its main distinguishing characteristics from other sedimentary rocks. First, we will see classification based on texture. Shell characteristically contain fine-grained silt and clay patches, and classified as silty shell and or clay shell. It is depending on whether silts or clays dominate in the constituents of the rock. Both are collectively called as argillaceous shell. And sometimes shells may contain appreciable amount of sands, in which they may be called as sandy shell. Next is classification based on mineral composition. Depending upon the predominance of minerals, shell is classified into three: quartzose, feldspatic, and micaceous. In quartzose, it is rich in free quartz, means quartz grains dominate the sample. Feldspatic, that is feldspar and clay minerals, are dominant. In micaceous, it is rich in muscovite mica and other flaky or clay minerals. Third, that is classification is based on cementation. Based on type of cementation or cementing material, shells, like other sedimentary rocks, are cemented by some minerals or elements after deposition and compaction. The dominant type of cementing material may be used in the classification of the shell. The common cementing materials are silica, iron oxide, and calcite. Accordingly, shells are classified into three types in cement based on cementation. That is siliceous, presence of dominance of silica; ferruginous, dominance of iron oxide; and calcareous, on the dominant of calcite. You can see images of a quartz shell and a micaceous shell. Next, that is fourth, it is classified on the basis of depositional environment. The sedimentary environment of any sediment rock is a natural geographical entity in which sediments are accumulated and later changed to rocks. Three depositional sedimentary environments are recognized, namely continental, transitional, and marine. Shells are generally deposited in lacustrine, that is continental, deltaic, that is transitional, and marine depositional environments, and may correspondingly classified as, such as lacustrine shell, deltaic shell, and marine shell. In lacustrine shell, it is characterized by mixture of clay, silt, sands, inorganic carbonate precipitates, and various freshwater invertebrate organisms. That is, you can find ostropods, gastropods, and various plant deposits. In deltaic deposits that are generally parallelic, that is consisting of orderly sequence of shells and sandstones formed as a result of alternating marine transgression and regression. In deposits of marine sequences, great depth, oxygen deficiency, that is in marine shells, there is a concentration of elite clay minerals, and there is the formation takes place with oxygen deficiency. Shells of marine depositional environment are generally darker in color and rich in marine planktonic fossils than shells deposited in lacustrine and deltaic environment. And thus, these these shells, marine shells, can be can have larger deposits of petroleum and petroleum oil and gas. Next is importance of shale. It firstly in commercially, shells are important in the ceramics industry to make bricks, tile, pottery. Shell used to make pottery and building materials requires processing besides crushing and mixing with water. And coming to the importance of shale in petroleum industry. In petroleum industry, the petroleum industry encompasses of exploration, production, transportation, processing, and marketing of petroleum, oil, and gas. The generation and accumulation involves three stages. That is, generation of source rock, migration through the formation, storage in the reservoir rock. Shales are the recognized source rocks because of their organic carbon contents. These organic contents, depending on their nature, depositional environment, temperature and pressure, and depth of barrier, are capable of generating petroleum, that is in the oil window, which differs in temperature till 150 degrees Celsius and high pressure. Petroleum gas is produced in Petroleum gas is produced in high temperature or pressure humic plant dominant organic sediments, while oil is produced from less humic fossil dominant and moderate temperature pressure marine shells. The shells have very low porosity and permeability. Shells have very low porosity and permeability, and thus petroleum once formed is trapped in the rock, but may move out due to hydrodynamic pressure conditions into nearby porous rock. The petroleum wells into the reservoir, as shells are impermeable rocks, are also important seals in sedimentary and structural traps, and shells therefore important as source rock, reservoir, as well as sealed rocks. And such reservoirs, according to Rogers in 1993, he has mentioned that about 90% of all formation drilled in petroleum industry is shales and limestone. That is, shale can act as source rock, it can act as a reservoir, and also as a seal rock. And before introduction, several years ago, once shale was considered as only a seal rock or a cap rock and not as a reservoir. After the introduction of hydraulic fracturing, the technology came, then it was said that it was found that shale can also be a reservoir rock and not just a cap rock. The technique, hydraulic fracturing, it is a technique in which water, chemicals, and sands are pumped into the well to unlock the hydrocarbons trapped in shale formations by opening cracks in the rock and allowing natural gas to flow from the shale into the well. When used in conjunction with horizontal drilling, hydraulic fracturing enables gas producers to extract shale gas at reasonable cost. To sum up, we will see the key points of the shale. Shale is the most common sedimentary rock, which accounts for about 70% of the Earth's crust. The defining characteristic.
Pushpa?
Yes, sir.
Yeah, okay. So you added on like we have started like US. What US is doing right now is about shale. They are producing shale gas, right?
Yes, sir.
Okay, so fine. You said like it was 100% right. Like earlier, there was no technology to extract the shale gas, but now we have that chemical by acidizing and then fracturing. We are able to produce the shale gas, right? So
Yes.
that is there. But till now, it was also a concern of environmental issues. Okay, when basically when you pump in the chemicals and all, so it might get the reason behind it was like we were not producing shale gas was one of the reason was the environmental issues. Suppose we are drilling with something, we are producing shale gas and we are pumping chemicals in it, and suppose if there is a contamination of water in contact with it or some other issues, so it might get an environmental issue. So it was one of the concern. Okay.
Uh,
Okay, go ahead.
So I will sum it up what we have covered
Okay.
in a key points. Then you can. As I was saying, the defining characteristics of the shell is its fragility. In other words, shell is easily divided into thin layers. Black and gray shells are common, but the rock can appear in any color. It is common to find limestone and sandstone lying near shell. Shell usually occurs on the levees. Roughly 55% of all sedimentary rocks are shale. Some shells are probably high in calcium due to the fossils they contain. Shell with high alumina content is used in cement production. The shell with a high natural gas content has recently been used as an energy resource. Approximately 95% of the organic matter in the sedimentary rock is found in shale or mud. Once formed, the shale is usually released into lakes and rivers with slow moving water. Clay is important component of shale. And with that, I will sum it up. Thank you.
Okay, Pushpak. It was really nice to enlighten us about shale. You covered up very good stuff. And okay, any other person who can want to ask question, they can ask him because he has already now done with his presentation. Anyone else? Hello? I think no one wants to ask question. Acha, anyways, can you okay? I'll go ahead. Can you one by one introduce yourself?
Hello guys, everyone.
Yes,
This
yes,
is
go
Sir,
ahead.
this
Okay, who is
So I will call out the names or I
yeah,
can
yeah, yeah, yeah.
unmute.
Go ahead, so that one by one can introduce. So I also get to know who is speaking.
Okay. Rahul Pawar.
sir, this is Rahul Pawar.
Then we have with us Karminder.
Okay, Rahul. One question to you. Can you
Yes,
just
sir.
give me your background? What is your PCM BSc?
Sir, I had microbiology, zoology, and geology.
Okay. Next.
Karminder.
Hello, I'm Karminder Kaur. I'm from Part 1 MSc, and my subjects in BSc were physics, maths, chemistry, and geology.
Okay, good. Next.
Sahil.
Hi sir, I am Sahil. I completed my BSc from Siagar College. My subjects were zoology, microbiology, and geology.
And okay, and one more thing, no one is calling me sir, okay? You can call me Shreyash. Next.
Prajwal.
Hello, Shresh. My name is Prajwal Vanjari. I am from MSc Part 1. I have completed my BSc from Navroji Wadia College, and my subject were physics, chemistry, maths, geology.
Okay.
Rahul
Next.
Chaudhary.
Hello Shreyas, myself Rahul Chaudhary. I completed my BSc from MJ College Jalgaon and my subjects were chemistry, biology, zoology and geology.
Okay. Next.
Sumit.
Hello Shreyas, I'm Sumit from MSc Part 1. I completed my BSc from Navroji Wadia College and I also had physics, chemistry, maths and geology.
Okay. Next.
Siddhant. Uh, I think he has some problem. Mahima.
Hello Shreyas, I'm Mahima from MSc Part 1. I completed my BSc from Christ College and my complementary courses were statistics and chemistry.
Okay.
Ankush.
Hello, Shreyas. I'm Ankush. I'm from MSc Part 1. I have completed my BSc from Navroji Wadia College and my subjects were physics, chemistry and geology.
There is one more fellow Jilster, but I don't know his name. He's just fellow Jilster, so he can introduce himself.
Okay. Okay. Anyways, so let's go ahead. A very good afternoon to everyone. Okay. So basically, the reason is for conduct. I was like asking you guys to come up and share something so that you also guys will come to know. Like you will be also be confident enough later on in your semesters and in interviews, so that will be good for you also. And the thing is, now what I want to say is, like, suppose the people who are with maths, physics and that that will basically be good enough for you guys to understand about the physics, because there is too much of physics in drilling, and maths is obviously there are too many calculations also, and electronics is also is much of it. So the guys who are with maths, physics and electronics, they will be will have upper hand. Other guys, you, if you have a knowledge of it, you are like good to do with physics, maths and electronics. Or if you can do it, start doing on maths, physics and electronics, because it's much needed in oil field. Okay, for even for mud logging, even for MWDs, even for DD or for log analyst. Okay. Hello.
Yes, sir.
Yes, sir.
So now, so have you, like, anyone have thought of it, like which field you want to choose? Like, suppose if I ask Pushpak, so which field do you want to go? You want to be into mud logging, MWD, or log analyst, or you want to be a mud engineer, or a coil tubing part, or something else?
So I would like to be a directional driller.
Okay, fine. So can you just, like, I'm not judging you, or like, just I want to know, like, how far you know about it, like till what extent. So like when you say you want to be a directional driller, so what are the things you should know to be a directional driller?
Sir, uh, in my view, the calculations, the graphical knowledge, playing with the graphs, that is axis, be it the 2D or the 3D, and spontaneous decision making. That these are the key factors that I think that are required for being a directional driller.
Okay. So I'll just enlighten you about it, like what all things direction driller would need. Okay, will need. So when you say you want to be a direction driller, so you should know each and like the drilling operations, right? The entire drilling, how it takes place. Like suppose when we start drilling, so from the start, from the scratch, when you say you have tools, right? You have a
Yes.
BHA. Now, when you say you have a BHA, that is BHA stands for borehole assembly, right? From which from what we start drilling. So you should know about what is BHA, bottom hole assembly, what is called as bottom hole assembly. So how it is described. So let me just describe in short. There are too many things to cover up in it. So when we start with bottom hole assembly tools, so it first start what will with what we drill. We drill what thing is drilling the formation. What is drilling? It's a bit, right? Drill bits, right, Pushpa?
Yes, sir.
Okay. So in order to, there are n number of bits. There are various number of bits. Like if you go in classifications of bits, so you have got like PC. One is tricon bit, then PDC bit. There are different types of PDC bits. Then so you should know what bit should be used in what field, like in which zone we should use which bit, right?
Yes, sir.
So later on, you have got like tools like now when we say RSS, that is like rotary steerable system. So what does it do when we say mud motor? So that is also basically directional tool. So there are two tools like directional. For directional driller we need two tools, right? One is like the thing how we can just divert the well, or so it is RSS, and there are two, we distinguish in two, RSS and mud motors, right?
Yes.
So, so you should start learn if you want to be direction driller. So you should start get to what I can say is like start looking for bits, like what bits they are, like what bits in hard formation they use, in soft formation what bit is used. So what bit is used for kickoff, what bit is used for like what which bit is effective in which formations, right?
Yeah, okay.
Okay, so start to know those things, and then when you these are the direction driller, and then direction driller decides like what parameters it should be, like weight on bit, then how much torque it has to be, then ROP, then all sort of parameters, RPM, then these all things has to be covered up by direction driller. So, okay, this is like in two details. Okay, let's start from, I'll just start with an basic, like what we should do as a fresher, and we can discuss, discuss on that. Okay.
Okay, sir.
Okay. So now first thing, okay, fine. You get an interview call from, suppose you get an interview call. Okay, fine. Today is your interview for mud logging. We'll start with the mud logging. Okay.
Okay, sir.
So you are like you have a very good interview. You cleared everything, and now you are about to join the company. Fine.
Yes.
So what do you think? Like, what would be the next step?
It will be a training.
Okay, fine. So after that, when you start, after you clear an interview, you are hired by a company. So next point will be your medical test.
Okay.
So basically, you have to be you have to be medically fit. Okay. So guys,
Yes.
that is also one key point. I have seen people getting who are unfit and they were rejected. Okay. So focus on that also, like थोड़ा उसके ऊपर भी ध्यान दो, health के ऊपर भी ध्यान दो. So that will benefit after a year, like थोड़ा. So if any problem, like it's not that major thing, but still, okay. So okay, now you are like okay, we're fit to go on the field. So suppose we are going on the field. So suppose if a mud logging unit is been transported to the field, and you are on the field. So what would be the first thing you will think of? Like what you will do?
So to understand the region or the rig to its
Yeah.
various its
Yes.
parts and all.
Yes. That is absolutely right. So you will first thing as a fresher, you will start looking for the things like what part is called what. So basically, if we talk about the rig, so you will come to what is doghouse, what is mast, what is rotary table, where is rotary table, where is V door, where is BOP, where are the pumps, where are the mud pits, and then the tongs. So these are the components of the rig. Okay.
Yes, sir.
Okay. Now your unit. So basically, you are like your unit is on the field. Now what you will do? You have seen anyone has seen the unit? How the unit looks like?
No, sir.
Okay, so it's like a you have seen the bunkers like suppose length of 10 feet and a box kind of a thing like
Con- Container.
yeah, container, right, container. So in that the entire system has been fitted. Okay.
Okay.
So the first thing we have to go on the field, then we will see where to place our unit. Like there are, you have a certain place where we have to place the unit. So suppose, and there are the zones. Now, for mud logging unit, it has to be in zone B or zone C. So zone A, the rig is categorized in like zone A, zone B, zone C. So it depends on your unit. So how your unit is manufactured, like they have got the ratings. So few units are you can put in a zone. Few units you cannot put in a zone because it is like explosive or like explosive area or like then if you have got like gas on the rig floor and it should be like 100% sealed. So those are the A zone units. Then B zone, actually all the units are like basically are certified for all the zones, but at few times they don't allow us to keep the unit in A zone. They don't keep allow us to keep the unit in the B zone. We keep the unit in the C zone. Yeah, this is a unit. Who's this?
Sagar, sir.
Okay, thank you, Sagar, for the slide, man. Okay, this is the unit. So this is the unit when we place it, and then now what we'll do to start the unit. So what we do is basically we go to the rig electrician. We need the power to power up the unit, right? Hello, Pushpa.
Yes, sir. Yes, sir.
Yes. So first thing what we'll do, we'll place the unit, we will see the area is okay to place the unit, everything is placed. Now next thing will be we have to power up the unit. So we need power to run the system, right?
Yes, sir.
Yeah. So what we do is we go to the
Uh,
electrician.
Electricians and also generators.
Yeah. So basically, we first no. One more thing, we cannot touch any of the things on the rig floor till we get the permission. There is a company man on the rig site. First, we have to go talk to him, say that we are on the site, we four people are on the site, we are here for mud logging, this is the unit, these are the certifications of a unit, then he will approve it. Okay, fine, you are free to go now. And then you will go and place the unit and then you start up your work.
Okay, sir.
Okay, so next thing what we will do is we go to the electrician, we ask electrician, so where are the generators? So now when we say power up the unit, so it has to has like proper voltage, right?
Yes.
So what do you think, like how much voltage do we need to run to power up the unit, and how much does the rig system has to power up the unit, like how much the rig system has?
So don't have generally I don't have idea,
Okay,
but
okay, no problem. I'm just making a conversation. Okay, so I know, even I was the same.
it can be 440 volts voltage.
Yes, correct. So basically, every unit has got their different ratings. So few may be like 360, one maybe 480. So depending upon the unit, we have to ask the electrician to power up to that slot. So
Okay.
okay, so we go to the generator, we say, now the electrician says, oh, we have got say we have only 360 volts, we don't have 480 volt slot. So what can be done? But a unit needs 480 volts to run. So what can be done?
Sir.
Because so that's what I asked you. That's what I asked you for the background, like who are the people with maths, physics, and electronics background, and so these are the things where the basic things will come into play. So, so that's what I wanted to enlighten you. Like these are also the things which we need to look on. And so now, when electrician says, okay, I have only 360 volts and your unit needs 480 volts, so now what can be done? So basically, what we can do is every unit has a transformer.
Yes,
What
sir.
the transformer does? Step up and step down. So now,
Yeah.
if he plugs in into 360, what you can do is you can do you go to the transformer, you step up the voltage, you go make it 480. So if you
Yes.
say if you want to run the unit on 360 or some other voltage, so you have to go and step down the power, right?
Yes, sir.
Yeah, so that is the first thing we do. So now we we lay the cable, we then we power up the unit, and the system is on. So now, so there are different sensors used to run the unit, right?
Yes, sir.
So any idea, anyone, not only you, anyone, do you have any, like anyone can just list out the sensors which are being used on oil field for mud logging or for MWD? Anyone? No problem. If you don't know, so you can say it. No, doesn't matter. Even I was the same. Even I didn't knew when I was in college, like what sensors were being used. I'm just asking you. Okay. Anyways, so different types of sensors which are used on the field are like pressure sensors. Then we have drawwork sensors. Then we have mud pit super sonic sensors. Then we have got gas system, and so hook load sensor. Then we have got RPM sensor. These all sensors we start to rig up. These are the sensors we place on the rig, and then from these sensors we get to know, we get the values on, from these sensors we get the values to our systems, right?
Yes.
Okay, so what does the pressure system will do, pressure sensor will do?
So it will calculate the pressure of the fluids which is while drilling.
Yes, okay, good enough. Yeah, so basically pressure is used to measure the pressure. What does a drawwork sensor will do is it will measure the depth. What will the RPM sensor will do is RPM will look to like what RPM we are giving to the string, and the sonic sensors will detect the mud pit volumes. Like we have a mud system, right, where we have to keep a track of mud in the pits. We call mud tanks as a pits, okay, on the field.
Okay, sir.
Okay. So basically, so that's what I wanted to tell you. Like these are the main like these are the sensors which we should know. So maths, physics, and electronics will really be helpful for you to understand the sensors, how it works. What so now there are different types of sensors. Now when we say what are the analog sensors, what are the digital sensors? So when we say analog sensor and digital sensors, how does it work? So when we say analog sensors, it will like read like from uh, in a value, not in one and two. Whereas digital sensors, it will read one and two. Okay,
Yes.
so this is how the sensors will take place, and then we start when after that we are hooked up all the sensors at the place. So where will be the pressure sensors? Yeah. So okay, Sagar. Thank you, Sagar, for this. This is like you can see my no, I have not shared my screen, right? Okay.
Yes.
Anyways, you can see that cable running to a drum. So this,
Yes.
so this basically this is like the draw work, what we call as a draw work. So basically there is a slot over here, slot there where we hook up the draw work sensor, and then it will start measuring. So before doing, when we install everything, what will be the next point to do? When suppose our sensors are all in the place, like at the draw works, at the choke manifold, then at the pit, and then at the where we want to place the RPM sensor, what will be the next step? Next step, obviously, what it sensors will give you a random values, right?
Yes.
So basically, we have to calibrate the sensors. So when next step will be the calibration of all the sensors. So
Yes.
okay, then after that, those sensors will read the correct value. So calibration is, your physics guys must know what is calibration, right?
Yes, sir.
Yeah. Okay. So after that, we calibrate the sensors. Now the sensors are there. We are about to start drilling. Okay, the BHA is picked up. Now, when we say BHA pickup, what does it stands for? Like when on the rig we say BHA pickup. So BHA pickup is like bottom hole assembly. We are taking part by part and we are assembling it on the rig floor. Okay.
Yes, sir.
Okay, so we first take the bit. Then, if you want to drill with mud motor, we will take a mud motor which is used to give direction to the well. And RSS is the rotary system and rotary steerable system. And then we pick up. After that, we will pick up the other components of the BHSA module. Actually, it is called as module. Like directional tool, you want to pick up the uh, directional, like which gives you the direction. Then you want to get gamma, or you want to have pressure, downward pressure. Want to have like resistivity of the formation. So these are like part by part. So what we do is like we start assembling it on rig floor. Okay, so
Yes,
that
sir.
is called BHA pickup. Then we are about to start drilling. So when we start drilling, but obviously we need a mud system, right?
Yes.
So what is mud used for? Like why is mud used?
Sir, for lubrication and basically for the lubricating while drilling.
And to
Oh
reduce the temperature of drill bit.
Yes.
yes. And obviously, when we are drilling, the drill part, whatever we are drilling the formation, the drill part, the part has to come up, right? We cannot go ahead,
Yes, sir.
right? So it has to be like pulled out. So what does a mud system do? What does the mud do? It basically gives you the lubricant, then the cooling of this bit system, and then uh, uplift the cuttings from the well, right?
Yes, sir.
So now, when we say uplift, so where from the well, it flows through the flow line. It comes to the shale shaker. Now, what does shale shaker does? Shale shakers are
Shell
basically,
shaker.
yeah. So shale shakers are basically where your mud and the cuttings get separated. Okay.
Yes, sir.
Okay. So now, when we and at the shale shaker we collect the samples. Okay. Now suppose it is already decided like how many meter sample we want. So suppose we are drilling at a depth of 100, and the company man says, or the requirement of the drilling department is like every 5 meter of sample. So what will be the next depth where we have to collect the sample? Anyone? Okay. So basically say 5 meters. So count from on the screen, when the depth sensor show you the bit depth or the hole depth, and we start drilling, and then from 100 meters you go to 105 meters. So that will be the point where you have to collect the sample, right?
Yes, sir.
Yes.
Yes. So at that point, from the unit, one guy goes and collects the sample at 105 meter depth. So now that sample, what we are collecting, is representing the formation for 5 meters downhole, right? From 100 to 105,
Yes.
right?
Yes, sir.
Yes.
Okay. So can you go to the microscope slide, Pushpa?
Yes, sir.
Can you go to microscope slide of yours?
Yes, sir. Is it visible?
Yeah. So this is how the sample will be there at the shale shaker. We collect this sample and we get into the unit to examine it under the microscope. So now when I said, you remember, I said like I'll go in detail like how the samples are classified, like how we describe it on the field. So when we say like 5 meter formation we are drilled and we are getting a sample of 5 meter, so basically you think like the entire 5 meter will be shale? No, right?
Yes.
No, it can be. It can be shale for 5 meter. It can be sand for 5 meter. It can be mix of sand, shale, and limestone. Right? You cannot. You don't know like what is like for the entire 5 meters, right?
Yes, sir.
Hello. Yeah. So basically, that's where we when we describe in percentage, because we don't know like it go from 100 meter to 102 meter it was shale, or from 102 meter to 104 meter it was sand, or from 104 to 105 meter it was limestone. We don't know. So looking at the sample, we describe it like we say 10% of shale, we say 15% or 30% of limestone, or like, so this is how the mud logging logs look like. So the yellow part what we can see is sand, depending on the percentage what you entered when you see the microscopic slide. So this is like the yellow part is the sand, this will be the shale, and then silt, whatever the whatever the sample looks like, you will describe it and you will feed it in the system. Like from 700, suppose this is a depth of 7600 to 7605, whatever the interval that has been decided by the drilling department of the for whatever the geologist decides it. So that is how we describe it. See, here we have described it, then we have described like shale, how is it like, what characteristics it has, sandstone, what is it, shale, what is it, depending on the percentage, we can see the log, this is how generated. Now, this there is only, this is how the scale for the graph looks like from 0, 50 to 100. So this will be the graph for like flow of g, maybe for rpm, no sorry, not for yeah, for rpm, then for like torque, or for like flow gpm, how much gpm you are like pumping. Gpm, now when we say what is gpm, that is gallons per minute what we are pumping. Okay, mud has been pumped, gallon, we calculate in gpm, that is gallons per minute. So that is how the now ROP is, when we say ROP, that is rate of penetration. And depth, you can see this is how the depth has been seen on the log. Every 50 meters we have been plotting for the feet, sorry, that's feet. So every 50 meters we are plotting for the log. And there will be the gas system, which is like continuously running, whatever the gases are coming out of the hole, that will be flowing through the flow line to the shakers, and then on the shakers you will be having a gas system which will continuously stir the mud and pull out the gas, and that is sucked by the unit there are the motor. There is a motor inside the unit which sucks the gas, and then from that it goes to the gas system, and then it will calculate how much, what is C1, C2. Now C1, C2, C3, C4, IC4. These are all the components what we can see that is measured in ppm. Okay. Hello.
Okay, sir. Okay, sir.
So now, so that was the reason, like I asked you to describe, like how we describe on the field. So this is basic idea of mud logging unit, how it runs. Now, and when you collect the sample, you have to collect in samples like 2 or 3 depending on the requirement. It can be and then we pack it on in the bags, small bags, and then we label it saying that you have collected the sample for this so and so depth. So like from 100 to 105 meter, this is the sample. Now next sample will be at 110 meters, right? Hello.
Yes, sir. 110 meters.
Yes. So now when it's 110 meter, you go to the shell shaker, you get another 5 meter sample and you collect it, you describe it accordingly, how much percentage of sand, how much, same thing, and then you label it. You take a 250 grams of sample and you put it in a bag and you label it on the bag saying that this represent 105 to 110 meters. Okay.
Yes, sir.
Okay,
Okay,
so
sir.
this is how the mud logging system actually basically works. So the point is, now you what all things are you are covering in the mud logging system? Like you are covering the geology part, right? You should know the formation, like what formation, how to describe it, how to analyze the cuttings and all, right? And then it comes like electronics part where the sensors are, how the sensors are working. Okay. Hello.
Okay, sir.
Okay. So
Yes, sir. Yes, sir.
so this is like the pits where is seen on the screen. These are the mud pits. So basically there are mud pits like yes, obviously there will be mud pits where we have to store the mud, and from here there are attached pumps over here to the pits. From here the pump pumps the mud. Okay. And we give mud pits different name depending on for what it is used. So for like when we are pumping through an active mud pit. There are reserve mud pit. So basically when we are drilling, the volume of mud is being displaced, right, to the well, right? So it is always getting empty, empty, empty. So at one point of a time, we have to refill it. So there are reserve pits from where we have to transfer mud, and we have to keep on preparing the mud to so that the entire whole section is filled with mud, right? Hello.
Yes, sir.
Yes, so this is how the mud system is. So on each
Yes, sir, yes.
so suppose there are 10 mud pits. So you will need 10 sonic sensors to install on each and every mud pit, mud tanks, or mud pit, mud tanks is one and the same. So each and every tank will need one sensor. So there will be like 10 sensors you will be placing on the pits. So this is how the mud system works. Okay.
Okay, sir.
Okay.
Okay, sir.
Uh, yes. Anyone has got any questions regarding like we are just covering up to like I'm just telling you how basically it works on the field. So anyone has got any questions like what else you want to know? So basic thing, if I have time, just go through the net and just check for the different components of the rig. So you get familiar with the rig parts. What is called swile? What is called? So basically, this is an old system where we are not using these days. This is like before top drive came into play. This is Kelly and all is wiped out now. We are using top drive. top drive is which from which we give the RPM and we use for drilling, which we give weight on bit and then no, basically not weight on bit. So basically RPM and rest of the things we have. This thing is connected to the drop drive. So go to the internet and try and find out the components of the rig, like what is drawworks, what is top drive, what are mud, how the mud pit looks, what are the pumps, what are the drill pipes, different types of drill pipes, and there are like drill pipes, different kind of drill pipe means there are drill collars, there are heavyweight drill pipes, and then pipes. There are got different pipes. So basically, what I want to know is what I want to tell you is like be familiar with the rig components. Okay.
Okay, sir.
Okay, and then mud logging. Okay, anyone? What does basically mud logging? Mud logging.
Yes,
What the word stands for? Mud logging. Okay. Anyways, what does logging means? Logging is like what? A record, right?
Yes, sir.
Yeah. So
Yes, sir.
basically, yeah. So basically, what we are doing is we are keeping the record of mud, right? So that's why it is called as mud logging. Okay.
yes, sir.
Okay, sir.
Okay. So whatever happening to the mud, whatever it is whatever the mud which is going in hole, the properties of the mud, viscosity, then the density, and then different all the properties. What we keep a record of it going in the hole and coming out the hole. So right. So we have to keep all the records, so get familiar with the mud system also, like what properties do we need to know, how it affects. So basically, if mud weight is not sufficient, what will happen to the well? We drill like overbalance and underbalance drilling, right?
Yes, sir.
Okay, so now see in the one more thing I can add on is like when we see in the figure this mud return line that is called as flow line, from where the mud is coming out from the annulus, it will come to the mud flow line, and it will from flow line it will transfer it to the shale shakers. Okay.
Okay, sir.
Yes.
Ah. So anyone any questions can go ahead. Hello? Sagar? Hello?
Yes,
Sagar?
yes. Hello, guys. Ask questions if you have any questions.
Sir, I think sir has lost his connection, but we all are there.
No. I heard him. Sagar has.
I'm here.
Okay, anyone questions? What else? Or else what you can do is whatever I have said, you can just go through on the net, just try to find out. And if you have got any doubts, whatever you want to ask, you can ask me, okay?
Okay, sir.
Okay, sir.
Because maybe
Okay, sir.
like basically you are not familiar with the things.
Sure, sure.
So I just want to make you familiar with what all things are on the rig, okay?
Actually, these guys, they have just finished. They'll be finishing their second semester now.
Yeah. Okay. No, yeah, I got it.
Yeah.
I got it, Sagar. Yeah, thanks for that. But the thing is, so guys, do you related the things how the field works? Hello, anyone?
Yes, sir.
So you are getting what I'm trying to tell you, like how the mud logging
Yes,
system
sir.
works.
Yes, sir. Yes.
Okay, so
Yes,
now
sir.
what you can do is like whatever I have said, whatever if you want to know, and later on you can go, later on you just go try and find out things on the net, and if you have got any doubt how it works and what how it is working, you can ask me. I'll let you know. Okay.
Okay, sir.
Okay, so start from like mud logging. What is
Yes.
mud logging? What is MWD? Basically, we can start from there. Like what all MWD needs. MWD actually, basically, when you see even the engineers, not even geology background, they are doing MWD. So basically, MWD is all about electronics part. Okay, you have got few knowledge, very little knowledge of geology. That is also fine, but for mud logging, you have to have like geology background also. Why? Because you have to describe samples. You have to describe the gas system. What is the gas? What is like the formation and all. So mud logging takes like electronics and geology part. Whereas MWD, you will basically have to focus on electronics parts and the physics part. Okay, then the calculation part.
Okay, sir.
And for the
Okay,
log,
sir.
if you want to have log analyst, if you want to be a log analyst, so what we have to do is like you have to be very good at logs, where we can and geology, how the logs looks like in different formations. So basically, you have to have an interpretation for logs like this, how the shale will be on the log, how the mud logging, the MWD sensors will show the graph, like how they sense and how much what parameters are showing. Depending on that, the mud log will generalize the interpretation. Okay, this is like shale, this is sandstone, this is say carbonates or something else. So geology for log analysis is very more important. They have to be very thorough with it. Mud logging also geology part and basics of electronics. Okay.
Okay, sir.
Okay, sir.
Okay, sir.
Okay, Sagar. Any questions from your side? If you want to know what I can more brief them.
Yes.
Sir, I have one question.
Yes.
As our syllabus is strictly related to the drilling part,
Okay.
so can we enter the production job with this knowledge, or do we have to do any other things? Production.
Yeah, like. From my experience, I have not seen from our field many of them into production part. No one, I guess. I have not come into. Uh, I have not seen even one single guy who was into production part. So the
Uh,
production, yeah,
I
yeah.
don't think so, because
Pardon?
most of these guys were working in Halliburton, like coil tubing
Uh-huh.
and well testing, hydraulic
Ah,
fracturing.
yeah,
All
yeah,
that
yeah.
part comes under production only.
Okay, okay, okay. That way. Okay,
Yeah.
okay, that way. Yes, yes, yes. That way, that is also a different department where we
So,
actually. I thought like
so
production. What he's trying to ask me is the production part where we come into play into reservoir.
yeah, reservoir there are very few.
Yeah,
But
reservoir
when
very
you
few.
talk about this hydraulic fracturing, coil tubing, workbore operations, well
Yes.
testing,
Yeah, yeah,
so
yeah,
there
yeah.
are many guys,
Yes,
and
yes.
syllabus also covers that part. In the last semester, they'll be studying production operations.
Yeah, yeah,
Okay,
yeah.
sir.
That is true. If you are considering that part into production, yes, yes, yes. Surely you can go into production also. And even the one guy who had entered into reservoir. I don't remember his name, but there is one guy who is into reservoir engineering also. So
Yes,
yes,
those who joined industry in the initial stages in 90s, uh, those guys they have gone into reservoir and all, but now it has become difficult.
yeah. So anyways, you can go in field anyways if you choose to, but then you have to prepare it accordingly. Got my point?
Yes, yes, yes.
So if
Yes,
you
sir. Thank you.
if you're going for a reservoir engineer, so basically you should have that ability to uh, crack like when you go for an interview for reservoir. But obviously then you have to have an entire knowledge of like reservoir. What is the porosity? What is permeability? And then what saturation factors and all everything. So you have to prepare accordingly for your reservoir interview.
Okay, sir.
So, and when we say MWD, so you have to be prepared with your electronics part. So where basically how the sensors basically work, how the pressure sensors work, how the gamma tool works. So what gamma? How the gamma is detected by the sensors? How the gamma is detected? There are different types of gamma sensors where we have got gigamolar tubes and then iron crystalline. So there are different types. So basically, when you go for an NWD, so make sure that you have that sensor part very thorough.
Okay, sir.
And when you go for mud logging, so basic of electronics and geology, oh, but obvious you need a much more. You will be very good at geology as we are covering much of geology. But then yes, you have to know the sensor part also. So there is no limit like we can go into this field or that field, but then prepare accordingly.
Okay.
Okay, sir.
Yeah, basically now when I say prepare accordingly, that doesn't mean like you're going to just focus on MWD, okay, sensors, and you are going to keep the rest of the things aside. We have to cover up that also. Okay.
Yes, yes, sir.
Yes, sir.
Okay. Okay, Sagar, yes.
Thank you very much. Yes.
Yeah. So tomorrow, who is tomorrow night? Who is the next? Like I think Core was going to give on carbonates, right?
Yes.
So when is it feasible for you to cover it up?
Actually, Rahul was saying that he will give tomorrow. So I was planning for day after tomorrow.
Okay, no problem. So you can just make a thing between you guys. Who is going to present today?
Yes.
Okay.
Yes, sir.
Thank you, sir.
Thank you, sir.
Thank you.
Yeah, go through the
Thank you, sir.
search for the different
Thank you, sir.
with that. Okay, you have time so you can utilize it. Hello.
Huh?
So your voice is not.
Now is it fine?
Yes, sir.
Okay, so anything else you can just ask me tomorrow or day after tomorrow.
Yes, sir.
Is it okay? Chalo guys, then see you. Hello?
Bye, sir.
Bye. See you tomorrow.
Thank you, sir.
Thank you.
Thank you, sir. Thank you, sir.
Yes, sir.
Yeah, no sir, yeah, please.
Yeah.